Swayam Prabha. Digital India. Educated India.
Hello everyone. So in this lecture we will discuss about designing strategically for preventing pollution such as air, water, noise, light, radiation, etc. So if you see the kind of selected pollutants over here, they are given on this actually slide. So the maximum scale of a problem which is being caused by these pollutants, so we will see the scale of it on the time scale and on the a local to a global scale, how they are impacting. So how soon they can actually start actually having some impact, okay, on the given location, or how long till how long they can actually keep exerting their impact and the effect in the long terms. So if you see here in this first bubble, so this is SO2, NO2, NO, NH3, and PM10, etc. So these actually compounds, they can immediately actually start affecting, okay, within the a matter of hours till a days, and they immediately start exerting their impact in the on the a local actually place. So if you see their average residence actually time in the atmosphere, for how long they actually can stay in that a particular place or the atmosphere, and the maximum extent of their impact, till how long they can actually last. So this is what actually being discussed over. So we saw SO2, NO2. So these compounds actually from hours till days, they can affect at the local level. And further to this, if you see these compounds, okay, so 4, NO3, NH4, PM 2.5. So these are actually compounds which can actually affect any a local to a regional the level from days till weeks. So if they are kind of excreted in any place or any atmosphere, they are going to be there for several weeks. They can be there and they can spread to up to a region of a region. So region can extend from in the hundreds of kilometers. So this is how they can actually create their impact. If you see next to it a tropospheric ozone and all, so these can have their impacts from ranging from weeks till several months, and they can go up to an extent of a hemisphere level, they can go up to an extent of maybe half several countries they can catch. They can hover over maybe a continent or two. So this is the extent at which they can cause their damages. Even the same is this for a CO also. This can have its impacts from ranging from months till several years, and this can also spread over several continents. It can cover a major actually portion of the globe. And if you see other compounds CO2, CH4, N2O, SF6, HFCs and HCFCs and CFCs, etc. Well, we are all aware of the causes which these actually these compounds actually do. So the kind of harms what they do, so acid rains, the kind of global warming, all of these greenhouse effects, etc. they are all caused by most of these actually compounds. Even the depletion of ozones is because of these CFCs. So such actually compounds can last in the atmosphere for several centuries, and they can actually affect the world at its a global scale, that they can affect actually this entire planet if we see. So this is the extent at which these compounds can have their impact. So we must actually take care of these compounds to minimize actually the impact on our life on the on this planet. So this I wanted to actually bring to your notice at the beginning of this lecture, because these are the some compounds and chemicals which are very crucial, which are very critical for actually maintaining the balance on our biosphere. So let's see this how this phenomena actually this whole atmospheric pollution phenomena, all of this phenomena of several kinds of this pollution. So what are the effects and causes? Okay, so we will discuss one by one. So this, if you see this atmospheric pollution phenomena, it causes, obviously we are all aware of this ozone layer depletion. So it works for depleting actually the ozone, which is the safeguarding actually these protective like a layer in the top of our like a atmosphere in the higher altitude, which covers the entire globe. It saves us from the like ultraviolet radiation from the like a space, from the like a sun, and it creates a, like a habitable actually atmosphere on the like a lower side of our planet, on the like a on the surface of this planet. Okay, and there is like a photochemical and with the classic smog actually related problems, okay, which create actually the sky gets filled with the like a smoky shooty material. There are like suspended particles in the air. It creates actually problem for the like a the oncoming of the like a fresh air and the ventilation and even the light. It creates like a problem for actually aviation industry. So such kind of like effects are there. Then it causes like a acid rain. So several actually parts of the world, several parts of the like different countries, they have experienced like at several times these acid rains. So acid rains are actually because of these like chemical compounds which gets accumulated in the sky. They interact with the clouds, okay, and they come along with the rainwater to the like a ground surface. Okay, and while they come down at the ground surface, they obviously cause like a several types of like damages to the like a crop, to the agriculture, to the like animals, microbial life, to the even humans. So they actually cause several kind of situations. They cause sometimes like a skin diseases also if like one receives like a such water on their like bodies. And the suspended particles, well, the fumes generated from the manufacturing units, factories, even the fumes generated from like other like machines, heavy equipment, they get actually very fine dust in the form of like a fine dust. It gets like a suspended in the air, and it creates actually a problem. Okay, and then of course there is the next one, this indoor air pollutions. Since there are several actually appliances and equipment which we are using these days very frequently, so these units are actually responsible for creating like a pollution in inside the actually spaces inside the buildings. So there is a need actually for checking these indoor air quality also, for actually maintaining its balance. And on overall sense, this atmospheric actually pollution phenomena, it causes actually global warming. We are all aware of there is accumulation of like GHG gases in the atmosphere, and in overall terms, like the Earth's average temperature is slightly increasing like every like a few years. And what are the like human health effects observed through this like oxidative stresses are like becoming actually normal. Carcinogenicity is becoming actually normal because these compounds are highly toxic in nature, and they exert actually such like a reactive like a thing on the human skin and on the human bodies that it can develop into like a cancerous growth also in the body. And if you see that the ecosystemic effects, they create actually selective pressure, they create actually damages to the like coral reefs, they actually cause damages to the like a forest. Okay, it causes like several like forest and huge swaths of like green vegetation areas to actually simply like die off these like situations. So there are actually several kind of efforts what we can see over here from like a normal human being to like the life of like a animal like world if we see, or the even the like a vegetation world if you see, there is so much of effect happening. And when we see like the effects of the like on like a biochemical like cycle, so in the like COs, CNs and the CSI, like carbon like silicon compounds, carbon like nitrogen compounds, carbon like oxygen compounds. So these actually there are several ranges, several like a series of compounds which cause actually reactions of like a biochemical like a cycles, and they actually disturb actually biochemical cycles in the like organisms. And if you see like here in the coping mechanisms, so they help in there are actually we need to like evolve like a coping mechanisms where one can actually have some preventive actually measures taken for the actually design of like our like gadgets and utensils and built environments. So resulting like a pollutants, if you see like a GHGs, photochemical oxidants, okay, there are some like a priority pollutants also which create actually pollutions. And then the human driven like a air chemistry, if you see like reactions and transport, like here if you see like some effluents which are coming out of like a certain industries, they actually create problems in these areas like specifically. Okay, human use of chemicals, if you see here like a combustion based actually exhaust, industrial process based exhaust, the waste releases to the like a compound, okay, in form of like a in the like a gases to the air, in form of like effluent in the water, in form of like other solid like waste and effluents in the like soil. So in an overall sense, they create like a problem in these. And in the chemicals, if you see like a earth crust and mantle, atmosphere and ocean biomass, so the overall actually there are like a impact. So it starts from here. Okay, there are like, these are some chemicals. Okay, then the use of like how we are using these chemicals, then how the human society is driving actually these chemicals, then the how they're turning into like to pollutants, and how this whole pollution is causing these many problems what we just discussed, like ozone layer depletion, the acid rain and global warming, etc., and how the human health is affected, how the ecosystems like balance is actually getting a hit. Okay, and how it is affecting the overall like a biochemical cycles of the like a living organisms. So this is the kind of a chain reaction you can see over it. Starts from here and goes on till like a indefinitely. So it has actually reverberating and long lasting actually effects on the ecosystem and the well-being of like living species. So if you see like as we saw in the like a previous slide, so there is actually a sequence of actually how these chemicals, how these compounds actually are traveling actually in this like a biosphere. So how they are making their actually way into the different domains where they haven't been earlier. So from like a one place to another, and from from that place to the next one, this is how actually they are traveling, and they are creating actually effects of like a several actually kinds, whether it is like a biological, chemical, or even like atomic. So some how to go for like a risk assessment actually processes. So we will see like the stepwise like for the hazard identification. So like it identifies the type and nature of adverse health effects, okay, on the like human beings. And it actually studies like for the human studies, it studies like animal based actually toxicological studies. It takes like in vitro toxicology studies, structure activity studies. So by conducting these many like several types of studies, we can understand what kind of like hazards are like can be associated with like such chemicals and such compounds. This data is actually released by World Health Organization in the year of like 2010. So, and how to like characterize this like hazards. So qualitative and quantitative descriptive like analysis can be conducted, and based on like several like such like analytical like methods, we can actually characterize the hazard like limits of those actually compounds and chemicals. How we can do this exposure assessment? So evaluation of concentration or amount of particular agent that reaches the target population. So we can assess the magnitude of it, we can assess the frequency of it, we can assess the like how long, how like was the duration of this. We can assess the route of it, like how well in which way and on through which like actually circuit it is following the actually its route, okay, and up to what extent it's causing the damage. And how we can go for the like risk characterization, advice for like a decision making. So these actually this can help into like a taking decision as far as like a policy making and things are concerned, so that we can create actually cohesive actually place of like a sustainable growth and development model. So it's like the simple example you can understand, like the chemical based like affluent based industries should not be actually placed next to any residential area, obviously, because that's going to create like a impact to that particular place. And any place of like habitation should not be exposed to actually such like a units. So such kind of actually policy making decision can be actually taken care of through like studies like a probability of like occurrences, like how like frequently it's going to happen, the severity and the extent of it, in the given population in that given place, and several like other types of like uncertainties are also involved with like such chemicals which are not completely known yet. So those also can be assessed, and a policy decision actually can be taken care of. So you can see through like these pictures how the some like places, some rivers have been like polluted in the like first half of this previous century, and how it was transformed by like a serious effort from the like government agencies and governments itself. So this is the Sumida river in like 1967. As you can see, it's like a highly polluted and damaged. Actually, all of the like aquatic life at that time was almost completely gone. This is a scene from like a country of like a Japan in like year 1980, and then in the 1983 it got actually reformed and corrected, and you can see the view over here in this particular this second image. So there they have actually tried to restore, and almost they were actually successful in restoring the actually ecological balance of this river in this particular place with the conscious effort. Okay, same some examples from like a Japan. So this is a first picture is from like a 1960. Okay, and how it got transformed. So you can see the spillover of like chemical compounds and hazardous waste into the seawater directly over here. Okay, and how they took actually corrective measures, how they actually brought actually enforced like laws and rules and regulation to bring checks and measures on like such industrial actually places. Okay, this problem was highlighted by our National Geographic. Also, you may have seen actually this the cover page of this magazine. Okay, this is a piece of like a plastic which is floating inside the like a water body, and it is shown as this planet of like a plastic. So it looks like a piece of an iceberg. So what we can see, the extent of pollution these days is very little, but it has the potential that it can damage up to much larger like extent. So that's the actually message one can actually draw from like this cover image, which is quite literal. We have all seen like the pollution caused by the plastics in our like surrounding areas. So the one fact which is given right here on this cover page, you can read like 18 billion pounds of plastic ends up in the ocean each year, and that's just the tip of the iceberg. Well, that's what they mean to actually say over here. The extent of pollution what we are seeing, what we can see is just a little part. The kind of extent it has and it is having on our like a ecological balance is really immense that we can't even measure. So plastic we all know is a recent actually industrial like a invented actually material which came actually recently, not very long ago. 150 years ago we actually created this plastic. It is very lightweight, it is strong, and it is a very cheaper material compared to like other like packaging materials whatever are available in the market today. And this actually miracle material has helped us also for like a several like requirements for like a packaging, for our like a carrying like a liquid based substances, and it has plastic has impregnated almost like everywhere. Even our these computers, these desktop, even our mobile phones, all the most of these electronics, most of our like household appliances, almost every article today has at least one or two plastic components, or that entire component or the entire that product is made up of plastic. It has impregnated like so much. So as this fact actually states over here in this National Geographic actually magazine, it talks about more than 40% of it is used just once, then it's just thrown, and it's gone out of like a your control, and now it is going to end up somewhere in the maybe a water body, or maybe on some landfill or somewhere. It's going to be there somewhere for a very long time depending upon its grade, and it cannot be actually disposed of like properly if it is not disposed of properly. Some 9 million tons of it end up in the ocean each year. That's a huge amount if we see, and that is why actually there are some satellite images which are indicating like there is a huge actually volume of this plastic based actually waste and garbage material which is just simply floating across the like oceans from one place to another, and is causing actually severe damages. We have seen in the previous like lecture how the animal life, how the bird lives, they are eating on these like a plastic waste, and they are actually dying, they are simply dying out of it. So if you see like a working life of one like a single plastic bag which we usually get on any like a shop in the market is just for 15 minutes. And for the purpose serving of this 15 minutes, this plastic bag is going to last in the like a ecosystem for like a several years. So you can see in this like a graph over here on the left side, like how is the lifetime of plastic like extends. So like how the like a plastic evolved, and how it has actually scaled up the volume of the use of the plastic, like how it has like scaled up. So you can see in the packaging 161 million actually this million tons of this plastic material is used in just like a less than like a 6 months time. And if you see in the like a consumer products, this is used like a 46 million. It goes on in the like a ecosystem for like a 3 years. In the textile based actually waste, if you see it, this is used for like a it is thrown like a 65 million tons of this material, and it goes on there for like a 5 years time. So you can see, you can read on this left side, as it says like after lifetime of plastics, the plastic actually made from like a fossil fuels are just over a century old. They came into widespread use after World War II and are found today in everything from cars to medical devices to food packaging. Their useful lifetime varies. Once disposed of, they break down into smaller fragments that linger for like a several centuries. So this is how actually it keeps on lingering in the like a in the ecosystem. If you see over here in the electrical this thing, so 19 million tons of this waste was discarded for like 8 years, and then transportation like a 30 million, then industrial machinery like a 3 million, and then building and construction industry, if you see, like a 72 million. Okay, and the others, if you see, like a 52 million tons, including like healthcare and agriculture. The average time plastic are used before they are discarded. So here, if you see, this is the like average time which shows like after which it is discarded. So in the building industry, actually it goes on for like for up to like a 35 years, and then it is discarded. And the total, if you see, like 448 million tons of plastic was produced only in year 2015. So that's a huge amount, that's the amount we can't even like practically like imagine like how it would be, but we can see the reflection of it, like our planet is kind of like drowning in this plastic. In the growth in the Asia, if you see, this is at the time of the recession in the year 2008, there was a slight dip observed, but again it actually maintained its like a pace. So as the economies in Asia grow, so does the demand for consumer products and plastics. Half the world's plastics are made there, 29% in China only. So you can see like how the Asia is contributing to this waste of like plastics. So the more than half of it is produced only in Asia, and almost like a 30% only in China. Okay, let's see like the grades of the plastics. What are the grades, the common grades which are available in the market in the commercial like usages, and percentage of their like a global waste what they form. So as per this is a data from like a year 2015 taken from like a National Geographic. So there is like a challenge of recycling if it is not properly recycled. Okay, how long it's going to be there in the ecosystem, and how much bulk of that waste it forms. So the grade 1, actually this is PET, polyethylene like a terephthalene. So this forms actually the 11% of the total waste which was produced in the year like a 2015. The second one, HDPE, high density polyethylene, 14%. The third one like a PVC, polyvinyl chloride. So this we are all aware of. I think we have seen all of these plastics in our like a consumption. This forms like a bulk of like a 5%. LDPE, low density polyethylene, this constitutes for around like a 20%, very big. And then we have like a polypropylene PP, number 5, it constitutes for around like a 19%. Then we have like a PS, polystyrene. So this is also one of the very like a hard plastics which we usually like make with like for like plastic cups, the egg boxes, the meat trays, and the hangers. Several types of like insulating materials we use of this material. So this actually forms like a 6% of that bulk. And then we have like other very hard like polymer grades which is represented by like 7, for example, like nylon fabrics and ropes. Baby bottles, they are very hard. Compact discs like a CD discs. Medical storage containers, those are actually very hard actually plastic materials. Components from like any car or mechanical equipment. Water cooler bottles, those are actually the 7 grade actually plastics, and they constitute 24% of the total bulk which was produced in a year like 2015. Okay, and this is actually, if you can see this image, these are the actually pieces of like a plastic waste, and you can easily identify most of these from like a everyday objects what we use in our like daily life. Okay, so every piece of plastic here was found in the stomach of a single albatross chick. Okay, so these are not some random actually pieces of plastic collected from some dump yard, but these pieces were found inside the stomach of actually albatross like a bird. Okay, laid bare outside the actually bird it killed. The plastic pieces from the bottle caps in the top row to the tiny fragments along the bottom all represent actually parts of some like a product which we generally use in our daily life. So this actually these pieces were collected from like a remnants of a bird, and they were actually photographed by this photographer Mandy Barker. So this is actually extents of damage one can imagine this plastic is causing. So if you see like how the world looks like in a polluted world and how it should be, so it's a kind of a graphic illustration like how we should strive for like a balanced ecosystem based like a design. So how these like a industrial world, the features of the industrial world, the technologies of the industrial world which were actually very harmful, for example like radioactive materials for like a heavy discharging actually electrical or manufacturing like units, how we can actually replace them with the renewable actually resource generations, and how we can actually replace them with the much efficient and greener actually solutions from the use of the latest technology, and we can actually strive for the bringing back earth to a normal state. So this is actually an artist illustration you can see over here. This girl is actually kind of trapped in actually a suffocating actually environment of a city, and there are like a lot of gases and poisonous actually suspended like material in the air, and she's simply unable to breathe and open her eyes, and there is a ray of hope we can see on top of her head as a like a two leaves of a sapling. So these are some illustrations which are actually depicting the aquatic life, how the aquatic life is actually plagued with this the waste generated by these plastic. Another depiction like how this our food material is getting the concentration of actually poisonous substances and chemical compounds, like how those chemical compounds are actually reaching in our like a food chain, and how we are also getting affected out of that. So in this graphic also you can see like how pollution is actually affecting all of the ecosystem. So it's causing like a global warming situation, it's causing like light pollution, it's causing actually littering, it's causing air pollution, radioactive radiation, it's causing like a noise pollution, it's causing like acid rain. So there are actually various forms of pollution emanating from the same sources of like industrialized ways of actually making stuff. This is an image taken from like a Beijing, China. It shows actually the this is stadium, very famous stadium, on two different days when the sky is clear and when there is a like a sky is not so clear, and it is like inundated with the toxic like air. Again, another shot of a place from like Beijing. You can see taken on two different days, and how the pollution has actually entirely taken over the skies, and nobody is able to even easily breathe in this air. And you see the visibility has gone so bad. It shows actually the level of the concentration of this these toxic fumes and suspended actually materials, suspended particles in the air. Okay, you may be wondering what is it. It looks like a tasty piece of like a ice cream, but no. Actually, the water what you are seeing over here in the form of like an ice cream is taken from like a different actually places of pollution from like a different places. So whatever these substances you can see in the like as a suspended actually matter which are visible, like the pieces of plastic, the pieces of actually torn cloth, and some other like some living actually organisms, so and the dead particles. There are actually n number of things actually available in these actually frozen actually ice. Okay, but it is actually sourced from like a different places of like a polluted actually places, and that is how actually this the artist like a imagination, like how they have actually represented this thing. So if you like see this, the title given over here in this National Geography magazine is the pollution on a stick. These photographs are taken by Zheng Yu. So it says if you licked one of these treats, you will encounter cigarette butts, oil, oozing trash, and a whole lot of plastic and other unsavory pollutants. Three art students collected water from 100 sites around Taiwan and then froze it into the ice blocks. The artists Hong Yi-chen, Guo Yi-hui, and Jing Yu-ti hope to draw public attention to water contamination and inspire people to generate less waste. So you can see over here like a going from like a clockwise direction. The first one, in the top, it says like this water is actually was sourced from the ditch in the Zhongli night market. The next one was actually sourced from like a canal in Bangtuao, and then the next one is a ditch in the Shilling night market. The next one in Danshui River. Next one port of like Kulun. The next one is Xinjiang stream, and then the next one Shanshong Park. So these are actually different places from where actually these water samples were actually collected, and they have actually turned into like the pieces of like an ice cream intact. So how actually these pollution and pollution based actually effects can be actually controlled? So there are actually natural methods also available in the nature, from which actually these several types of actually pollution, for example water pollution is being talked over here on this slide, can be actually taken care of. So there are actually some traditional native and American and Mexican actually water purification method that uses the inner sap of the common cactus plant. The cactus substance presents an environmentally friendly, surprisingly simple solution to contaminated actually water. The cultivation of these substance and development of the purification method could significantly impact the lives of 1 billion people in the world who do not actually have access to clean drinkable water. The substance inside the cactus called mucilage keeps the plant hydrated. We may have actually seen, most of us may have seen actually these cactus plants. So even in the harsh like summers, they are always like they maintain their actually hydration level. Researchers have actually found that the sugar particles in the mucilage have the ability to filter contaminants such as like various chemicals and arsenic from polluted water. The Mexican water purification method is as simple as boiling the mucilage on a prickly actually a prickly pear actually cactus in contaminated water. The pollutants rise to the top and are easily scooped out of this the liquid. So this is how actually they have been traditionally actually filtering the water in the some parts of the America and the Mexican places. Another actually example taken over here, as you can see, is the garbage actually collector for the like a water bodies. So this is called as a water wheel. So the facts about this is like there are it has like two trash actually containment booms, so which actually collects the debris from the like a surface of the water. So it keeps moving. It keeps the the belt, which the conveyor belt, as you can see in this picture over here, and the whatever the trash which is there in front of it, it gets actually deposited in its like a belly, and it keeps on moving. This is the powered on the water itself, so it moves freely in the water, and it keeps actually collecting the debris. So you can see over here the debris raking system helps to move trash and debris to the front of the conveyor belt. Further, the conveyor belt actually lifts trash and debris from the water body. The sail actually fabric cover protects the water wheel from wind and rain. This top portion over here, the part 4 here, and the fifth one, the water wheel actually harnesses the current of the river to turn the conveyor belt. The dumpster barge actually stores trash and debris, and further once that is collected, one can actually collect this trash from the like water body. Let's see another actually example where we will see like how the garment as a like a material, as a like a as a material, it flows from like a from it's like a beginning of the life until the end when it actually completes its life cycle. So we will observe actually like how it carries its journey over like a longer period of like time. So this is the global material flow of garments. So you can still see it starts at point 1 over here. Okay, as the material flow actually from here it starts. So 53 million tons of like a annual like a fiber production for like a clothing actually takes place, and it starts from here. And then this fiber actually production and the processing goes in like a different countries. Okay, and like for example, if you see like here the Vietnam, China, Bangladesh, Pakistan, Australia. Okay, and different countries have like a different actually capacities, and that is how actually it gets processed, and again it goes for like a transportation and reaches to the markets. So it starts from the like a United States. It's at the level 1 and goes for like a processing in these many countries. It comes back again for the supply and sell here in this market of the United States. So yeah, and from here again it goes for like a packaging and supply to like a different places, different cities of the United States. So in the container it gets transported, as you can see over here, 16 million tons. So garments usage in the United States is almost this much, and now it reaches to the like supermarkets and shops from where it gets actually sold off. So this 4 points you can say, and from here actually starts this waste actually going to the landfills in the US. So from the once the actually the garment is discarded, it reaches to the landfills. Okay, and then from these actually garment waste selling to the even a major portion of this actually garbage actually is sold to like a Bangladesh. You can see over here 0.08 million tons of it is sold to the Bangladesh. Again it reaches over here in the Bangladesh, and then it starts actually creating a like certain like issues over here. It goes for the like a landfill, it goes for like a recycling. So several types of like a some treatments, whether it is treated or not, it ends up actually in these like many places you can see over here. Okay, and then this is actually map of actually landfills in the Dhaka, which it says. So there are several locations it talks about where there are like a landfills created for like a dumping actually such waste. And it here it actually comes to the end, well not a practical end, but at least it stops here for like a further movement. Okay, so this is the actually journey of this material, and on the 7th part you can see the textile wind recycling industry. So there is a whole full-fledged actually recycling industry in the places, in the countries of like Bangladesh and Vietnam and some more countries from where actually they do the recycling, and some again actually some recycled fabric or the yarn out of that, they go back again to the EU and US, and that is how actually this whole you can see a cycle over here. So this cycle is actually connected at the global days in the global level in actually these times. So this is how actually globalization has played a role in actually affecting each and every corner of this world through some way or the other. In this actually slide we will see like the amount of like input in the energy, input in the like metals, input in the terms of like minerals and chemicals, in the biomass and water, is divided for like these many sectors for their services. Okay, and then it goes into this what kind of like emissions. Okay, and what kind of actually processings are actually done with these. So let's see the first one, like 8 million megawatts of like energy goes for the like households, industry, offices and retail. Okay, almost 700 kilotons of like a metal goes to serve these four sectors. Then 1600 kilotons of like minerals and chemicals actually go for like serving to these actually sectors. And then there is a water. If you see 19 million actually cubic meter volume of water goes for like serving these four actually sectors of like household, industry, offices and retail. And in terms of like output, they generate actually, you see in the terms of like emissions, 20,500 kilotons of like emissions are generated out of these four. and 6,900 kilotons of like a waste is generated, and 110 million cubic meter of like a waste water is also generated out of like these four actually major large consuming actually industrial sectors. And out of that, in the waste, if you see how much of waste is like a processed, so 590 kilotons of like a waste is actually processed for like a high value like a reuse, and then 5,000 kilotons of like a waste is like a processed for like a low value reuse. 740 kilotons of waste is used for like a incineration like a facilities for power generation or simply burning the waste, and 400 kilotons of waste is anyways landing into the landfills. So this is actually life journey on overall scale, you can see, of like resources, like how they are being utilized and how they are turning into such a waste for the this planet to handle. With this, I would like to come to an end of this lecture.